Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called float fill. So in this problem we have been given one image and in the form of two-dimensional array of integers, right? And each number represent a pixel of image, right? And what we want to do, we have been given the coordinates, right? What is the row and column coordinates, and we have been given the new color as well, and we want to fill our old color to the new color, right? So that's what we want to fill this image matrix. So let's say I just copied the same example here as well, and we have been given this coordinate first, so first row and first column, and then whatever the four directionally it's created, I mean it's connected. So if you read this, plus any pixels connected four directionally to those pixels also with the same color as the starting pixel, and so on, replace the color of all the aforementioned pixels with the new color. So we need to basically color with the new color with all the connected old color. So let's say this is old color, so what I would do, I would just replace this with a 2, and this is also connected with this, so I will replace with this as a 2. This is 0, so this is not eligible. Downstairs this is not eligible, and this is 1, so it will be replaced to, and this will be replaced to, this will be replaced to, and this will be replaced to. This one will not be covered. So if I'm talking about this one in the black color, this will not be covered because this is not connected with the old color grid, right? So this is the similar problem that we just solved with the maximum area of Iceland or number of Icelands, and the only difference is basically we have been given the number of coordinates. And for example, let's consider we are if we don't have if we don't have been given the number of if we don't have been given the coordinates itself, then the challenge will be like we have to scan the whole matrix itself in the two for loop or so, right? But as we have the access of coordinates, that we already know that we have to start our search from the first coordinate, first row and first column. Then we can spread our search basically from this pixel basically to all the neighbor pixel that's having the old color, right? So that's the advantage, and we don't need the for loop here basically because we already have the coordinates, right? And that's the reason we don't need to scan the whole array, whole two-dimensional array itself. So let's try to create a couple of placeholder, that how we would do the depth first search in this case, and then we will come back here and then we will try to write on the our code, right? So what we can do, like for example, if we have to replace with the new color, right? And let's assume like if about the old coordinates that's already having the new color, then it means we don't have to replace, right? So we will just go ahead and return the same array itself, right? Or let's say if image is null, or image start length that is equals 0, or it is new color, right? And then we will create our helper method that's called dfs, and in this method basically we will try to fill our matrix, right? Int sr, int sc, int new color. Another information, we would need the old color, because if you observe like in this diagram, what we are doing, we are replacing 1 to the 2, so we know that what's the old color, right? So old color in this case is 1, but it can be anything, it can be 3 or it can be 5, right? So in this case it's 1, so we need that what is the old color, so that we can just find it out the all the four direction, right? So in this case our base condition would be like if this row itself is less than 0, or it is getting out of boundary, right? Same is 0 dot length minus 1, right? And another important base condition would be like if if it is, let's say for example, if it is not equal to old color, right? If it is not equal to old color, then we are not going to do anything. So that's why we need to put in the base condition itself. And let's say SR and SC we will be filling with the new color itself, right? And then similarly we will just go all the four directions here. So let's do that. Image SR plus 1 SC, new color, old color, and let's go all the four directions, right? So SR plus 1, SR minus 1, SC plus 1, and SC minus 1, right? So SR plus 1 means down, SR minus 1 is up direction, this is basically right direction, and this is basically left direction. So that's what we have to do. So here if you observe, like we are not maintaining, we are implicitly maintaining as a visited here thing, because anyways we are doing the recursive approach and depth first search we are doing here. So implicitly it's visited itself. So why I am saying visited, because we are just checking if it is not equal to old color, means the constraint have already been given in the question itself. So we don't need to explicitly say okay, we don't need to mark it as a visited or anything, so that we can check in the base condition. But if you see, like indirectly we are just marking it as a visited. So what I am doing, we are just painting with the new color and we are assigning okay, this is the new color. And similarly we are just checking okay, if it is not equals to old color or not, right? If it is not equals to old color, then means if it is already new color, or it may be some other color, not old color, then it does not make sense to do that again. So that's why this important base condition is here, right? And definitely we would try to dry run itself, right? So after dfs we will just go ahead and return our grid. So image SR SC, and new color, and old color would be current pixel. So SRSC. And if you observe, like I already mentioned, that we are not doing the to for loop because it's really not needed. We have been given already the coordinates from where we have to start the search, and then from that search, from that point. So in this case, let's say if I'm painting with the yellow color, right? So sorry. So if I'm pointing with the old yellow color, this is the coordinates that I have been given 1 and 1, right? So this coordinates is 1 and 1, first row and first column, and I am spreading my search deep, basically depth first way, from this coordinate itself. If I don't know this coordinate, then definitely I need to scan the whole matrix, but I don't need to scan the whole matrix because I know that from where I need to start my search, and I go all the four directions here. So if I have to dry run this code, basically what it's doing, it will just come here. I start from 1 1, and that's definitely not the new color, so it will not return from here. It will come here and it will just check the base condition. It's not the old color, I mean that's the old color itself, right? And then it will mark this coordinate as a new color. So what it would do, it will just mark it as a 2 here. Then it will do SR plus 1. So SR plus 1 means it will go down. When it will go down, it will hit the base condition, and that's 0. So 0 means it's not 0 means, what does that mean? It's not old color, right? 0 is not old color. Old color means it should be 1. So it will just come back, recur to this condition through this cell wherever it started, and then it will hit again the SR plus 1 has already been completed, so it will just go to the next line, and that's SR minus 1. So SR minus 1, it will just go to the above cell, and it will just mark it as a 2 here itself, and then it will um, uh, just go to the recursion, and then it will mark it as a 2, and then it will just go to the SR plus 1. So SR plus 1 we already covered and it's already visited. SR minus 1 we already covered and that's already visited. Now it will just do the SC plus 1. So SC plus 1 means this thing, and this thing was basically earlier one, right? So what it will do, it will just mark it as a 2 itself, and then it will just go to the recursion again, and then it's checking like what is SR plus 1. So SR plus 1 is 0, again hit the base condition, it will come it again here, and then SR minus 1 is nothing, so it will hit the base condition, like it will return, Then sc plus 1 is also nothing because it's out of boundary, so it will just go to the sc minus 1. So sc minus 1 is nothing basically, and then from sc minus 1 basically what it will do, it will cover this cell itself, right? So whenever we mark it as a wish state and we were in this cell, right? And then from the sc minus 1 itself, from this cell we will, if we go to here and then it's already 2, then the control will come to the here, and then it will just go all the 4 directions, and then it will just go to again here. So I just directly jump to the next step, but this is how the recursive, it will just go every each and every cell, it will just visit, and then it will just mark it as a 2. So this also it will mark it as a 2, and then similarly it will just do the again thing sr plus 1. So sr plus 1 means it will go down, it will mark it as a wish state, then again go to the recursion sr plus 1, it will mark it as a wish state sr plus 1, and then once it marks and then complete the recursive call, it will get out from the call stack, recursive call stack, it will just check the sr minus 1. sr minus 1 is already 2 here, so it will just return from here, right? And then from the base condition, then sc plus 1 also it will check. Sc plus 1 means whatever in the next column, and the next column itself is a 2, so it will just return from the base condition. And then sc minus 1, sc minus 1 means like it is already hit the base condition because it cannot be less than 0. It's already, it should be in the boundary itself, right? So then it will hit the base condition and then it will return, and then probably it will just return from the caller to the caller itself, and it will return the updated image, right? So if you observe the all these recursive calls, if you observe the pattern, wherever we are finding the old color, that's 1, then we are updating to the new color, and wherever we are not finding the old color, we are just handling that in the base condition. So we cannot say that we are not marking it as wasted. Here we are marking it as wasted, and that wasted is a 2 itself, right? So that's what we are internally, we are indirectly we are just using the wasted pattern itself in the recursion. So I hope this is clear. And if I quickly calculate the time and space complexity, so time and space complexity would be n and n, where n is the number of pixels in the image. So when I say the number of pixels means total number of items, how many items are there in the image. In the worst case it can be all the old color, so I have to traverse each and uh, every item in the index in the array, and this is due to the implicit stack, right? Implicit recursive stack, recursion stack. So implicit recursion stack would still take some space, right? So that's why it will be just traverse through, it can traverse through each and every element of the two-dimensional array in the worst case. So that's why it will be the order of n. But however, I did not try to compile this, so let's quickly see if there is any error. If there is not any, then just quickly try to submit and let's see how it's going. So looks like this is working fine, and hopefully the explanation is not confusing and it makes sense. Let me know how it goes, or if there is any confusion or any question, then I can probably try to reply and can try my best to reply all the other questions. Thanks a lot. Have a good one. Bye.